Okay, so if we have the fifth root of 243 and x to the 10th, when we deal with the numbers, I can just plug that into my calculator. I can take the fifth root of 243 and I can get that answer. And then I can think about this problem conceptually. Let's take a moment and take the fifth root of 243 and tell me what you get. Addie, what did you get? 3. Now let's take a moment and decide, is this a plus or a minus 3? If you think it's plus or minus, give me a thumbs up. If you think it's not plus or minus, right, thumbs down. Give me a thumbs down. Plus or minus? That's correct. It is not plus or minus. And the reason for that is that it is an odd number here. And when it's an odd number, the sign and the sign matches. So now what about this x to the 5th? Let's do this conceptually. So, I'm sorry, x to the 10th. I need to figure out how many groups of x to the 5th I have. And I can pull out, if I have an x to the 5th, I can pull out 1. So how many x's do you think I can pull out? Who thinks they know? How many x's? Go ahead. David, how many x's? I can pull out 2 x's because I could rewrite this as x to the 5th times x to the 5th. And when I have x to the 5th, I can pull out an x squared. Now, let's do this problem algebraically. Okay? That was kind of the conceptual way to solve it. And now let's think about this algebraically.
Wait, are you always pulling out, when you have like an x 10 or whatever, are you always pulling out that root right there?
Yes.
Out of it?
Yes, you're always going to pull out this number out from whatever you have. So I could rewrite this as 3 to the 5th. I could rewrite this as the 5th root of 3 to the 5th times x to the 10th. What's your question? Did you have a question earlier? Yes, let's do it algebraically the way that you're describing. So I'm going to show that algebraically. She's saying, well, I can do an exponent to an exponent. So what I'm going to do now is I'm going to rewrite my radical without a radical. I'm going to write it in its exponent form. Right? So I'm going to take what's under the radical. I've got 3 to the 5th, or 243, x to the 10th, and it's to what exponent? What exponent am I going to write it to up here? 1/5, right? 1/5. And that's notation, and you've got your form, and you need to learn that notation. So this comes and goes in the denominator. Now, when we have an exponent to an exponent, I multiply my exponents. So this becomes 3. And the other thing I can do is I can think about this as distributing this through the parentheses. So I'm going to have 3 to the 5th, 3 to the 5th, to the 1/5, times x to the 10th, to the 1/5. All I've done there is I've just distributed my exponent through the parentheses. Whenever we have parentheses, we can distribute that through the parentheses.
So we didn't multiply those then, you just...
Yeah, now I'm going to multiply them. You might have skipped this in between step and gone ahead and done that. That's fine as long as you do each and every term. So this becomes 3 to the 5/5. Whenever we multiply fractions, I multiply straight across the top and straight across the bottom. So I have 5/5. And then I'm going to have my x will be x, and this is 10/1. Whenever I multiply fractions, I multiply straight across the top. 10 times 1 is 10. And I multiply straight across the bottom. 1 times 5 is 5. And now I can reduce this. 3 to the 1st power, this is 1. We can write the 1st power if you need to, but you need to get out of that habit soon. We can just leave it alone. There's 1 3. I know that's 3 to the 1st. And this is x to the 10 divided by 5, which is squared. And I look up here, conceptually, it's the same way as solving it algebraically.
Okay, so, all right.